Here's number 4. So this one, the way that I did it when I was initially writing this was to use conservation of energy. You can also do it with just straight up kinematics as well. So I know some people did it both ways and got the same answer, which is good. It's good that they both got the same answer. So if we're going to do it with conservation of energy, we can start off with our whole conservation of energy equation. We've got initial kinetic plus initial gravitational equals final kinetic plus final gravitational. Alright. So now we got to think about which of these goes to 0. Hopefully a lot of them makes it simpler. So if we place our coordinate systems here, basically that the initial gravitational potential is 0. We can get rid of that. And then it wants to know how high that the block reaches before it slides back down. So that's going to be at that height, the velocity will go to 0, right? It'll be a positive velocity, and then it'll get to the point where it turns around, go to 0, and then start being a negative velocity when it slides back down. So the final, when the block is up here, just before it turns around, the final velocity is going to be 0. So our kinetic final is also going to go to 0. Yep, so that's it. So now we can plug in our definitions for kinetic and potential gravitational energy. So we've got 1/2 mv squared equals mgh. Once again, this is why I didn't give you the mass for this problem, so it cancels out as well. So we can divide both sides by mass. And we get 1/2 v squared equals g times h. We're trying to solve for h, so we can divide by g. H equals v squared over 2g. I suppose I should have a v initial, right? v0. But that's the only velocity we have, so it should be pretty clear. Okay, so that's it. We can plug in some numbers now. So I've got 4 meters per second squared divided by 2 and g. So I get h equals 0.816 meters per second. So that's going to be this height essentially here, right? The height above its initial height. So that was it for that one. Really simple if you did it with conservation of energy. I think it was a little more complicated if you did it with kinematics, but hopefully you got the same answer. So that's number 4.